When privacy work stays at the level of values and intentions, teams can sincerely agree that privacy matters while still shipping systems that overcollect, retain too long, or share data in ways nobody can fully explain. The bridge between intention and reality is a set of measurable goals that tell everyone what success looks like, paired with system specifications that make those goals achievable in the actual product. For brand new learners, this can feel like a shift away from privacy principles and toward engineering language. But the point is not to make privacy cold or technical. The point is to make privacy dependable, so the organization can demonstrate what it does, verify that it works, and improve it when it does not. Measurable goals prevent vague promises like "we respect user data" from turning into endless debate, because they define concrete outcomes like what data is collected, how long it is kept, and what choices users have. Aligning specifications turns those goals into built-in behavior, so privacy is not a fragile hope, but a design property of the system. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful place to start is to recognize why measurable goals are so important in privacy, especially in product environments that move quickly. Teams can rarely argue with a clear goal like retain account logs for 30 days unless there is a documented exception, but they can argue endlessly about whether a retention approach feels appropriate. Similarly, teams can implement a goal like collect approximate location only when the feature is active much more reliably than they can implement a general idea like minimize location tracking. Beginners sometimes think measurable goals reduce privacy to numbers. But the truth is that measurable goals protect privacy because they remove ambiguity that can otherwise be exploited by convenience and habit. When goals are measurable, teams can test whether they are meeting them, and leaders can allocate resources to close gaps instead of relying on assumptions. Measurable goals also help with accountability because they clearly define what was intended and who owns delivery. Without measurable goals, privacy becomes a matter of interpretation, and interpretation tends to drift toward whatever is fastest. To set good goals, you need to translate privacy principles into outcomes that can be observed in system behavior, not just in documentation. Data minimization becomes a goal about which fields are collected and whether any sensitive fields are excluded by design. Purpose limitation becomes a goal about which uses are permitted and how the system prevents reuse for unrelated purposes without review. Transparency becomes a goal about what information is shown to users at decision points, and whether those explanations match real data flows. Retention becomes a goal about how long specific data types persist in primary systems, logs, and backups, and whether deletion is enforced consistently. Access control becomes a goal about which roles can view which data categories, and whether access is logged and reviewed. Beginners often try to set goals like improve privacy or reduce risk, which are too broad to guide design. A sharper approach states goals as observable behaviors with clear boundaries, so anyone can inspect the system and see whether the goal is being met. Measurable goals also need to be tied to a clear purpose and a clear risk story, because goals that are disconnected from a reason tend to be ignored when deadlines tighten. If the purpose of a feature is to deliver package updates, then the goal might be to store contact details only as long as needed for delivery and customer support, not indefinitely for future marketing ideas. If the purpose is fraud prevention, the goal might be to use only the signals needed to detect abuse and to avoid building long-term behavioral profiles that exceed what is required. If the purpose is usability improvement, the goal might be to collect aggregated performance metrics rather than user-level browsing trails. Beginners sometimes assume privacy goals should always be as strict as possible, but strict goals that block legitimate needs can lead to workarounds, which are often less safe. Good goals balance user protection with real product needs by making necessity explicit and by setting limits that prevent creep. When the reason is clear, teams can defend the goal and adjust it thoughtfully when reality changes. A common beginner trap is setting goals that are easy to measure but not meaningful, which creates a false sense of progress. For example, Counting the number of privacy trainings completed may show activity, but it does not prove that systems minimize data or honor deletion. Another trap is setting goals that are meaningful but not measurable, such as ensure fairness, without defining what evidence will demonstrate fairness in the system's outputs. Measurable goals should be designed so that meeting the goal actually reduces risk or increases user control, not just improves a dashboard. They should also be designed so they can be verified without heroic manual effort, because goals that require constant human checking are likely to fail over time. Beginners often underestimate how quickly systems evolve and how easily drift can occur, so goals must be resilient and tied to automated controls where possible. The best goals produce clear signals when something changes, such as a new data field appearing in telemetry, which allows teams to catch problems early. Meaningful measurement is what keeps the program honest. Once goals are set, the next challenge is aligning system specifications, because goals do not enforce themselves. A specification is the set of requirements that engineers, designers, and operators build against, and it needs to define how the system will behave in ways that satisfy the privacy goals. If the goal is to avoid collecting sensitive fields in analytics, the specification must define exactly which events exist, what fields are allowed, and what filtering will block forbidden fields. If the goal is short retention, the specification must define retention periods per data type, how those periods are applied in storage systems, and how deletion will propagate to derived data and backups. If the goal is meaningful user choice, the specification must define what settings exist, what each setting changes in data flow, and how the system ensures choices are honored before data is transmitted. Beginners sometimes think specifications are only for features and performance, but privacy outcomes depend on specification discipline because privacy is implemented through system behavior. When specifications include privacy requirements with the same seriousness as functional requirements, teams can build privacy into the product rather than bolting it on later. It is also important to align specifications across the full data lifecycle, because privacy goals can fail if they are implemented in only one layer. A goal about minimization can be defeated if a front-end stops collecting a field but a back-end log still captures it, or if a third-party component adds it automatically. A goal about deletion can be defeated if the primary database deletes records but the data warehouse retains them, or if support attachments persist in ticket systems. A goal about purpose limitation can be defeated if a dataset created for security is later shared into marketing analytics because the system has no separation controls. Aligning specifications means ensuring each system that touches the data has requirements that support the goal, including integrations and downstream consumers. Beginners often picture a single pipeline, but real environments are networks of systems that copy, transform, and share data. A privacy-aligned specification, therefore, describes not only one component's behavior, but the relationship between components, including what data is allowed to move and what data must be blocked. When the alignment is end-to-end, goals become durable rather than brittle. User experience specifications are a major part of alignment because privacy goals often fail when users cannot understand or control what is happening. If the goal is transparent tracking, the specification must define what the user sees when they see it, and how the explanation matches the actual collection and sharing. If the goal is meaningful consent, the specification must define how consent is recorded, how it is stored, and how it influences data routing in real time. If the goal is user access or deletion, the specification must define what the user can request, how the system discovers their data across stores, and what confirmation is provided. Beginners sometimes treat user experience as separate from privacy controls, but in practice, user experience is where privacy promises are experienced, and confusing design creates mistrust even when back-end controls are strong. A well-aligned specification ensures that the language used in settings and notices corresponds to specific system behaviors, such as disabling third-party sharing or reducing collection frequency. When user experience and system behavior match, transparency stops being a marketing story and becomes an honest description of reality. Access control specifications are another place where alignment matters because even minimized and well-retained data can cause harm if too many people can view it. If the goal is least privilege access, The specification must define which roles can access which categories of data and what workflows require elevated access. It must also define logging of access, periodic reviews, and safeguards for support workflows that might otherwise expose sensitive content broadly. Beginners sometimes assume access control is purely a security function, but it is also a privacy control because it limits misuse, curiosity viewing, and accidental exposure. A privacy-aligned specification will include controls around exports, because data often leaves protected systems through exports into documents and spreadsheets where protections are weaker. It will also include controls for vendor access if vendors operate the system or provide support. When access control requirements are explicit, teams can implement them consistently rather than relying on informal norms. Alignment here means that the access model supports the privacy goals in daily operations, not only during audits. Retention and deletion specifications deserve special attention because they are easy to promise and hard to implement across real systems. If the goal is to delete and use data after a defined period, the specification must define what counts as the start of retention, what counts as deletion, and how deletion works in systems that replicate data. It must also account for logs, backups, and caches, because these are where retention often quietly becomes much longer than intended. Beginners often assume deletion is a single action, but in distributed environments, deletion is a coordinated behavior across multiple stores, and it needs clear ownership and verification. A privacy-aligned specification might require that all systems storing a data category support configurable retention and that retention settings are enforced automatically rather than by manual cleanup. It should also define exceptions and how they are approved, because legitimate needs sometimes require longer retention, but exceptions must not become the default. When retention and deletion are specified precisely, the organization can verify compliance and reduce long-lived exposure that otherwise accumulates unnoticed. Vendor and third-party specifications also matter because many privacy goals are defeated at the boundary where data leaves the organization's direct control. If the goal is limited sharing, the specification must define exactly what data is sent to each provider, why it is needed, and what restrictions apply to secondary use. It must also define how vendor changes are monitored, such as changes in subprocessors or default data collection behaviors. Beginners sometimes assume a vendor integration is a single decision, but vendor systems evolve, and updates can expand collection or retention if not governed. A privacy-aligned specification also defines offboarding behavior, such as data return and deletion at termination, because lingering vendor data can undermine user deletion commitments. It should include measurable requirements like retention limits and access controls that the vendor must meet, not just vague claims of security. Alignment means ensuring that your privacy goals do not stop at your system boundary, because users experience the combined behavior of your organization and its providers. Another key to alignment is making goals testable through acceptance criteria and verification steps that fit normal delivery workflows. If the goal is to prevent sensitive fields in telemetry, verification might involve checking event payloads before release and monitoring for violations after release. If the goal is honoring user choice, verification might involve testing the system under different settings to confirm that data flows change accordingly. If the goal is short retention, verification might involve confirming retention settings in each storage system and validating that old records actually disappear when they should. Beginners sometimes treat verification as an audit activity, but it needs to be part of delivery because discovering misalignment after launch is expensive and often harms trust. A privacy-aligned specification includes not only what should be built, but how the team will prove it was built correctly. When verification is explicit, the system can be monitored for drift, and the organization can respond quickly when changes introduce new risk. Verification turns goals into outcomes rather than wishes. Measurable goals also need to connect to governance so that when systems change, goals and specifications are updated intentionally rather than silently eroding. Product roadmaps introduce new features, and those features often create new data flows that can conflict with existing goals if no one revisits assumptions. A strong approach defines triggers that require review, such as adding new data categories, increasing precision of location, introducing new third parties, or changing retention periods. It also defines how exceptions are handled, because sometimes a goal must be adjusted due to legitimate needs, but that adjustment should be documented, approved, and bounded. Beginners often think governance slows teams down, but well-designed governance reduces friction by preventing late-stage surprises and by providing clear rules for when review is required. Alignment means that the program has a mechanism to keep goals and specifications current, which prevents the system from becoming a patchwork of outdated assumptions. When governance is connected to measurable goals, the organization can show progress over time and can demonstrate why certain trade-offs were accepted. That record becomes valuable when questions arise later. It is also worth recognizing that goals and specifications must be written in language that different roles can use, because privacy is delivered by teams with different perspectives. Product needs to understand what user outcomes and constraints exist. Engineering needs precise requirements to implement. Security needs clarity about threat paths and controls, and legal needs assurance that commitments are met. Beginners sometimes write privacy goals in a way that only privacy specialists can interpret, which leads to inconsistent implementation and frustration. A better approach uses plain language with precise definitions, such as specifying exact data fields, exact retention periods, and exact behaviors under specific settings. It also uses consistent terms across documents so teams do not debate what identifiers or tracking mean. When language is shared, alignment becomes easier because teams can coordinate without constant translation. Shared language also supports training and onboarding, which reduces drift when staff changes. Privacy by design depends not only on technical design, but also on communication that is accurate and usable. As goals are implemented, the program needs feedback loops so it can learn whether the goals are realistic, whether they reduce risk, and whether they need refinement. This is where monitoring becomes essential, not as surveillance of users, but as monitoring of system behavior and control health. If monitoring shows that sensitive fields keep appearing in logs, the goal may still be right, but the specification might need stronger filtering or better developer guidance. If monitoring shows that deletion requests take too long because data is spread across too many stores, the goal may need enabling platform work to make it achievable. Beginners sometimes expect goals to be perfect on day one, but in practice, goal setting is iterative, and maturity comes from refining goals as evidence accumulates. The key is to refine thoughtfully rather than weakening goals whenever they are hard, because hard goals often point to valuable improvements. When feedback loops exist, the program becomes a system that improves over time rather than a set of static rules. Metrics should support decisions and remediation, not merely produce status updates. Setting measurable goals and aligning system specifications is ultimately about making privacy operational, testable, and durable as products evolve. You start by translating principles into observable outcomes, anchoring each goal to a clear purpose and a real risk story so it stays meaningful under pressure. You avoid vanity measurement by choosing goals that, when met, actually reduce exposure or increase user control, and you ensure the goals can be verified without constant manual effort. You align specifications across the full data lifecycle, including collection, sharing, access, retention, and deletion, so the goal is not defeated in downstream systems. You treat user experience as part of the specification because transparency and control must match system behavior to preserve trust. You make goals testable with verification steps integrated into delivery workflows, and you connect goals to governance so changes trigger intentional review rather than silent drift. You use shared language so product, engineering, security, and privacy can build against the same expectations, and you maintain feedback loops so goals and specifications improve with evidence rather than with guesswork. When these practices are in place, privacy stops being a fragile promise and becomes a measurable, design property of the systems people rely on every day.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.